Let's go ahead and talk about polarity. So, a molecule is going to be polar if it has an uneven distribution of electrons. This uneven distribution of electron creates a partial positive and negative end on the molecule. So, how we can determine polarity is going to be first asking whether or not there are electronegative difference, and then is the shape symmetric? Now, I have included a pretty handy flowchart on here as well. So, are there lone pairs on the central atom? If the answer is yes, that will immediately make it polar. If the answer is no, that takes us to the other question of are the outer atoms different? If the outer atoms are different, it will be polar. If they are not different, it will be nonpolar. Let's go ahead and take a look at an example. So the first thing we would have to do would be to draw the Lewis dot structure of this. I'm going to go ahead and draw out the Lewis dot structure for our SiO2. So if we take a look at this structure, the very first thing that we're going to ask ourselves is, are there lone pairs around the central atom? We'll notice that there are no lone pairs around our Si. So this takes us to our next question of, are the outer atoms different? In this case, the answer is no. We have oxygen as the outside elements, so this means that this compound would be non-polar. So there's going to be an even distribution of electrons in this compound. Let's take a look at our Br2s. Drawing out our structure, the first question that we're going to ask ourselves is, are there lone pairs around the central atom? The answer is yes. In this case, we have two lone pairs around our sulfur, so this would make this compound immediately polar. Let's go ahead and take a look at our CCl4. Drawing out this structure, we end up with our covalent Lewis structure of this. From here, asking ourselves, are there lone pairs around the central atom? There are no lone pairs around our carbon. And then our second question, are the outer atoms the same? In this case, the answer is yes. So this makes this compound nonpolar. Let's take a look at our pH 3. So our Lewis dot structure takes a look like this. The first question, are there lone pairs around the central atom? There is a lone pair on our phosphorus, which means that this is going to be a polar molecule. And that is going to be how we take a look at polarity. Now, we do need to go ahead and talk about intermolecular forces as well. So, our intermolecular forces are forces between molecules, and they will determine physical properties such as boiling points and melting points. So, our intermolecular forces are all about between how one molecule interacts with another molecule. Now, our first type of intermolecular force is something called a London dispersion force, abbreviated as LDF. Now, our LDF is weakest and it's present in all molecules, and it's going to be stronger in larger atoms or molecules themselves. Now, it is the only force in a non-polar molecule. So, in order to determine your intermolecular force, you do have to determine polarity. So, Our London dispersion force are only found in non-polar molecules. Our next type is going to be a dipole-dipole force, and these happen between polar molecules. So this is going to be when we have a partial positive attracted to a partial negative. And then our last type of intermolecular force is a hydrogen bond. This is our strongest intermolecular force. And this is a special type of a dipole-dipole. So this occurs when hydrogen is bonded to nitrogen, when hydrogen is bonded to oxygen, or when hydrogen is bonded to fluorine. So these are going to be a special type of dipole-dipole. So this is going to be a polar molecule, but specifically when we have hydrogen bonded to nitrogen, hydrogen bonded to oxygen, or hydrogen bonded to fluorine.